Have you ever wondered how the lithium inside your smartphone, electric car, and modern batteries is extracted from the earth? And beyond electric vehicles, lithium powers large-scale energy storage systems that help stabilize renewable electricity and reduce dependence on fossil fuels. As global demand for clean energy accelerates, lithium has become one of the most strategically important minerals of the 21st century.
From the smartphone in your hand to the electric cars on tomorrow's roads, one remarkable mineral is quietly powering the future.
The massive scale of modern mining powers our world. Subscribe now to dive deeper inside the process.
But where does lithium come from? And how is it transformed into the battery-grade material that powers our modern world?
Use it. Hidden beneath the Earth's surface lies one of the world's most valuable resources, lithium, the essential element powers. Most hard rock lithium originates from pegmatite deposits formed millions of years ago, where geological forces concentrated glaciers. Powerful hydraulic excavators remove thousands of tons of lithium-bearing rock every hour, beginning a journey that will eventually. These enormous haul trucks transport hundreds of tons of ore in a single trip, keeping the processing plant supplied around the clock. Before valuable minerals can be separated, the ore must first be crushed into manageable pieces for further processing. Automated conveyor systems efficiently move enormous volumes of ore while reducing transportation costs and improving productivity. Grinding dramatically increases the surface area of the minerals, preparing them for efficient separation during the next stage. Flotation technology separates valuable lithium minerals from waste rock by using carefully controlled chemical reactions and air bubbles. Chemical leaching dissolves lithium compounds from the concentrate, allowing impurities to be removed with remarkable precision. Advanced purification systems remove the remaining contaminants, producing the ultra-high purity lithium compounds required for modern battery technology. High-pressure filtration removes the final solid impurities, creating an exceptionally pure lithium solution ready for the next processing stage.
Controlled drying removes excess moisture while preserving the chemical quality required for battery-grade production.
Precise chemical refinement transforms processed lithium into the ultra-high purity compounds demanded by advanced battery manufacturers.
Every production batch undergoes rigorous laboratory analysis to verify purity, consistency, and compliance with international quality standards.
Advanced quality control ensures every shipment meets the strict specifications required by the global battery industry. The finished battery-grade lithium represents the culmination of one of the world's most advanced mineral processing operations. Fully automated packaging systems protect product quality while ensuring complete traceability from factory to customer. Automation improves efficiency, reduces handling risks, and prepares products for rapid worldwide distribution. From this facility, battery-grade lithium travels across the globe to power the next generation of clean energy technologies. Every electric vehicle begins with carefully refined lithium, making this remarkable mineral one of the foundations of the global transition toward cleaner transportation. From the phone in your pocket to advanced medical equipment, lithium has become an essential part of everyday life. Modern lithium production relies on strict safety standards, advanced monitoring technology, and continuous training to protect both workers and equipment. Responsible mining extends beyond extraction by restoring landscapes and supporting long-term environmental recovery.
Loop water recycling systems significantly reduce freshwater consumption while supporting more sustainable mineral processing. Artificial intelligence and automation improve efficiency, enhance safety, and optimize every stage of lithium production. The process is monitored around the clock, ensuring maximum efficiency, consistent quality, and safe operation. Innovation continues to improve battery performance, safety, charging speed, and energy density for the technologies of tomorrow.